Students, this is 4-6 part 2 and a little bit from part 1. Okay, hold on, I'm going to close the window because there's some noise out there. All right, 4-6 part 2. Today I want to talk about a couple of things. From part 1 I missed talking about the vertical line test. Now this is kind of important, okay? So here's what I'm going to do. I'm going to go ahead and plot these points 1, 2, 2, 3, 3, 4, and 4, 5. Okay, so you want to start at 0, 0. The first point is 1, 2. So I go 1 to the right and 2 up. The next point is 2, 3. So I go 2 to the right and 3 up. The next point is 3, 4. So I go 3 to the right and 4 up. And the last point is 4, 5, so I go 4 to the right and 5 up. Now, as you can see here, this particular set of ordered pairs makes a nice straight line. Okay, but one thing you can tell about this particular line is that it's not vertical. Okay, so this is a function. Because the given points, not so much that they make a straight line, but that they do not make a vertical line. Now, here's how you can tell if there's a vertical line. You simply take anything that's straight and you can bring it across there. Are there any points along this line that are up and down that are on this particular line? No. Or this particular shape. Okay. So if there was another point that was either directly above this point or directly below this point, then that would make a vertical point. If there's a vertical point, then it's not considered a function. Now, let me go ahead and do this next line. I have the point 3, 4, so it'd be 3 over, 1, 2, 3, and then 4 up. Hey, it shares a point here. Now I have 2, 1, so go 2 over, 1, 2, and then 1 up. Then I have 5, 6, so I go 5 over, 1, 2, 3, 4, 5, and then 6 up. 1, 2, 3, 4, 5, 6. There's another point that it shares. And then 2, 2. 1, 2, 1, 2. Another point that it shares. So this one actually shares a lot of the same points as the line that I had made, but not all of them. So I'm just going to use a marker just so we're not mixing the points up. So in this one, it goes here, here, and then it goes here. Now let me try my vertical line test again. Okay. There's no 2 points on top of each other there. There's no 2 points on top of each other there. But yes, there are 2 points on top of each other here. So the second one, since there are 2 points that are directly on a vertical line from each other, then that one would not be a function. Okay. So one way you can tell if it is a function or not a function is when you graph it. Okay. If any 2 points are on a vertical line from each other, then they are not a function. Well, I look at these points and think, well, how can I tell? What if I don't want to take the time to graph this? The way that you can tell if it is a function or not a function is if you have any repeating x values. If any of your x values repeat, then it is not a function. Now, you remember when we talked about a function, we gave the definition, okay? We said that a function has exactly one output for every input, okay? So if I'm looking here, this is the output for this input. I have 1 as the output for 2. Now I also have 2 as the output for 2. So in this case, there's 2 separate outputs for the same input, okay? So what that means is it's not a function because there's more than one output for the same input. So how does that work in terms of understanding the material? If you're looking at your set of ordered pairs, or you can have it as a domain and range where the ordered pairs are separated into x's and y's. However you do that, if any of your x values repeat, then that means it's not a function. Because if your x values repeat, then that means that you're going to end up with a vertical line somewhere in your graph, okay? If you get a vertical line, then for our purposes, that's considered not to be a function, okay? Now, some of you might be thinking, well, what if the y value repeats? So let's just say I put down another number here. We'll just put 3, 2. Okay, now let's graph that. 1, 2, 3. 1, 2. Oh, I see what I did wrong. Point should be right there. That's okay. Okay, so if I added another point here, then I would get a horizontal line. So a horizontal line is okay on your graph, but a vertical line is not, okay? And it has to do with the fact that the x values are considered the independent variable. So they should not repeat, okay? And I think I had made that point before earlier when we were talking about this, but I just want to show you how you can tell from the graph. Now, just another quick note. Let's just say you have a large domain and a large range, okay? I'm just going to say domain, and then there's a whole bunch of numbers in it. I'll just write numbers. And a range. And there's a whole bunch of numbers in it too. Okay? Now, let's just say I don't feel like taking all day. I'm just going to pick one ordered pair from this, okay? Or a couple of ordered pairs. And let's say I make a point here, and then a point there, okay? I just picked 2 of these because I don't want to take all day to fill out all of my domain and all of my range. So I'm like, all right, cool, this is a line, and it's also a function. So I'm looking at this and going, okay, this is a nice straight line, and it's not vertical. Let me get my vertical line test pen here. All right, there's no vertical points there, and there's no vertical points there, meaning any points that would be on the same line. Now, because I didn't finish filling out my function, what if I didn't know that my function is going to actually look like this, okay? Now, once you fill out all the points, you can see you have a different shape. This is more like a fish hook, okay? But because I only took the time to fill out 2 points, it looked like a line to me, okay? Now, if I do the vertical line test, I can see, okay, there's no point there. Oh yeah, there's 2 points that are on a vertical line. If I were to fill out a vertical line, I'll just do a little dotted one here just so it's clear. Okay. Yeah, those 2 points are on a vertical line. Or basically, especially if it's continuous, if your graph has any two spots that could be vertically one above the other, then it would not be considered a function. Okay? So it's another reason it's important to fill out all of the points in your given domain and range. Now, I want to talk about function notation. Okay, and that's kind of what part B is on. So let's take a look at what I mean by function notation. Oops, sorry, I just want to make sure we're perfectly on the screen here. Okay, function notation is a way to write an equation for a relationship if it is a function. Now remember, we can have a relationship, but it's not necessarily a function. Okay, and it can be a function. It doesn't have to necessarily make a line either. It can be a function that makes another shape. But let me give you a couple of hints. The first hint I want to say is function notation is used when you're focused on domain and range. Okay? So basically when you have function notation, what we normally call y is called f of x, which is the function of x. So if you were given an equation and we're told to graph it, like let's take a look at this one. Y is equal to negative 1.5x plus 4, and it has a given domain. Now, remember, the domain is just a fancy word for the x values of 1, 2, 3, and 4. Then what would the range be? Now, since I refer to this as domain, instead of writing y, I'm going to write the function of x. Now, when you write it as function of x, then the notation style is you have a slanted f, which represents the word function, parentheses with x in it. And then just rewrite the rest of the equation. Now, function notation can be a little bit confusing because then I say to myself, okay, if my domain is 1, 2, 3, and 4, and I substitute in 1, 2, 3, and 4 for x, do I substitute it here and here? Okay, that's a very good question. When you write it as function of x, which is written as f of x, so that's how you would say it, f of x, then it's written as the function times x, okay? But you want to consider this whole entire thing as basically just y, or basically it's just the variable that you're solving for. Don't think of it as a separate variable to substitute in. And I know that's confusing because x now all of a sudden occurs twice in your equation. So if I were to solve this, then what I would do is write my domain. I would write in my domain with the intention of solving it this many times. Okay, so my first number in the domain is 1, and then 2, and then 3, and then 4. So I'm going to go ahead and solve this each time. 1 times negative 1.5 is negative 1.5 plus 4 equals okay, so that's negative, so we would actually subtract. So subtract 1 from 4 is 3. Subtract 0.5 from 4 would be 2.5. So positive 2.5. So now the domain is my x value, range is my y value. So if x is 1, then y is 2.5. 2 times negative 1.5 would be negative 3. Negative 3 plus 4 is 1. 3 times negative 1.5 would be negative 4.5. Okay. Negative 4.5 plus 4 would be 0.5. So if that's 3, then that would be, I'll just write it like this, 0.5, just so it's clear. Okay. And then 4 times 1.5 negative would be negative 6. Negative 6 plus 4 is negative 2. And I think I forgot to write that that's negative as well. Apologize. Okay. So now we would have some points here. Now this one's a little bit complicated because you have a decimal in it and you have a negative sign in it. Okay, so just like I did here, make sure you go back and look and say, oh yeah, this one's supposed to be negative, that one's supposed to be negative. So you want to double check to make sure that that you're accounting for all of those little oddball things like negative numbers or fractions or decimals. Sorry, my cat's trying to get on the screen here. She's a very loving animal, but she has a tendency to get in the way. Okay. Now, another quick hint that I wanted to point out here is domain and range are often use set notation or roster form. Okay. Now, what do I mean by that? If you take a look here, usually when a domain is written, put it in roster form where you have numbers written in brackets, okay? And all that just means is this is the set of what your x values are, okay? So it's just going back into set notation, but it's just telling you the same thing. It's just not writing it as pairs. It's writing it as this set is your x values and this set is your y values. Okay. Here, kitty. You gotta step down, okay? Now, last thing I want to teach you for this particular lesson, again, there's all of these different names for your x and your y. And so your x value is your independent, your y is dependent. Your x value is the cause, your y value is the effect. Your x value is the domain, your y value is the range. Your x value is the input, your y value is the output. Your x value is x, and your y value is f of x, or function of x. Okay? So again, there are different names for the same thing, and each name sort of like kind of represents a different part of it. Okay? So, yeah, hope that makes it clear. Thank you very much for your time, and enjoy this video.